Hello, everyone. So today I'm going to be talking about a study that we did using co-registration of EEG and eye tracking to try and better understand the linguistic processing that's actually happening when people are skipping over words during reading. So when people read, they make very rapid eye movements, generally spending only around a quarter of a second on each word. And so I'm just going to play a video of what this looks like in real time with an eye tracker. Very quick. And in addition to just making these rapid eye movements and short fixations, people also sometimes just completely skip over words. So, even small variations in fixation durations and the decisions people make about where to move their eyes from decades of eye tracking research we know can be diagnostic of cognitive processing and just the underlying language comprehension that's ongoing. So, in addition to being reflective of potentially linguistic or higher level cognitive processing, we also know that skipping in particular is really driven by some low-level oculomotor factors. So word length is a very strong predictor of whether someone will skip over a word or not. And so a shorter word is much more likely to be skipped than a longer word. And also, we know that when people launch their eye movements from close to the upcoming word, they are more likely to skip over it than if they launch from further away. So this may just be kind of a situation where people have an optimal saccade length that they prefer. And so the fact that these are kind of lower level visuospatial features and not necessarily linguistic might suggest that word skipping is not really reflective of deeper linguistic processing. And so if that's the case, then what are people doing when they skip a word? Are they just kind of filling in the gaps and making it up as they go without processing the bottom-up information? And so they could just use rational inference to kind of figure out what would be the most likely thing that would have been in that position and move on just using that information. So, as an example of a noisy channel framework of language comprehension, the storyteller could turn any incident into an amusing antidote. So people are often able to just kind of repair that mentally and still comprehend what the meaning was supposed to be. And another similar example is word transpositions. So a lot of times people don't even notice that these words are transposed, and so you're able to just kind of continue comprehending without necessarily like perfectly identifying the bottom-up information. So, is word skipping just kind of noise in the channel, and we use rational inference to fill in the blank? And so another question is whether skipped words receive less precise bottom-up processing. And so, for example, if a word contains a typo and you skip over it, do you even notice that there was a typo in it? And so, does it just reflect the system's tolerance for a noisy and incomplete signal? So another account would be a kind of more linguistic account. And so this kind of requires that we think about parafoveal processing. So the only way you can really bottom-up process a word that you skip over is if you've done that parafoveally while you're looking at the previous word. And so we know that our brains can kind of look ahead to the next word and shift attention while you're still fixating on the current word. And we also know that word skipping, although it's very strongly driven by word length, there is some variance accounted for by word frequency and predictability. And it's also possible that word length and launch position effects, these kind of lower level features could be explained by just better access to the parafoveal information, because short words are closer to your foveal vision, and if you're closer launch position to the upcoming word, then you're, again, your eyes are closer to kind of or the upcoming word is closer to your foveal vision. So one paradigm that has been used extensively to study just how much processing is happening parafoveally, whether linguistically or kind of low level, is the gaze contingent display change paradigm using eye tracking. And so in this paradigm, there's an invisible boundary on the screen, and the display actually changes depending on where the eyes are. So if you focus on just the anomaly condition here, which is the one that's going to change, once people cross that boundary, it'll change to a different word. And so by kind of comparing an identical condition in which nothing changes to a condition where something does change, we can draw inferences about what type of information was accessed parafoveally and how deep that processing got. So I'm also going to just play an example of what this looks like in real time. Sorry, this is not real time, this is slowed down, but actual eye tracking. And so you're going to want to pay attention to the word winter here and watch when the eyes cross that boundary. So it happens so quickly, people often don't even notice it's happening. Most of the time, you can go through an entire experiment and no one's noticed that anything has changed when their eyes move. So we can use this paradigm to be able to tell how people are processing information that is not in their central vision. And so Schotter and colleagues did a study using this paradigm that kind of speaks to the amount of comprehension that's happening when a word is skipped. And so they had a display change where it was either an identical preview or a different word. And then afterwards they asked people, what word did you see, basically? And when people skipped the word, they were much more likely to report having seen the preview than the target word, which makes sense because they never landed on the target word. And so it seems like, the information that they got parafoveally really influenced their comprehension of the sentence overall. So if it's the case that people are able to comprehend information just from parafoveal preview, what would they do if they get something in the parafovea that just makes no sense and then they skip over it? And so Abbott et al. Were interested in looking at skipping rates on the word the, because it's so high frequency and it's a short function word. And so they found, and they also had a constraint manipulation, but the constraint was just main effects, there was no interaction, but they found that people skipped the word the, and so in these contexts, the word doesn't make any sense, it doesn't even fit in the context, and they skip that word more often than a word that made sense or was expected. So this suggests that people are making decisions about skipping that may not necessarily reflect kind of deeper comprehension of what they're reading. So to try and get at what exactly is happening in the brain when people are skipping over words, especially when they skip words that don't make sense, we decided to use co-registration and combine EEG and eye tracking to look at the brain signals that are associated with these behaviors. So we record the raw eye tracking data and the raw EEG simultaneously, and you can synchronize these things, and so then you're able to time lock to particular fixations, whatever fixation of interest you want to. And so in the current study, we time locked to the pre-target word, so the word people are fixating before they skip or don't skip the next word. and manipulated that parafoveal preview. So some advantages for this method relative to what people have done in the past, I think, is that a delayed behavioral kind of self-report measure doesn't necessarily tell you what people are doing in the moment and could be kind of the result of downstream integration processes. So this kind of gives us a in-the-moment look at what's going on in the brain. And when a short content word like the, it appears to be skipped automatically, is that word fully identified, or is there maybe some other mechanism where people are just kind of ignoring short function words or high frequency words? So using brain potentials and looking at these time-locked to parafoveal manipulations, we can get a better idea of the brain processes that are related to that. So the ERP component we were interested in for this study was the N400. And so this component is assumed to reflect access to semantics and binding of that information during word processing. And it is more negative for an unpredictable word that's less expected in a context, whether it's anomalous or just lower frequency and unexpected. And another interesting thing about the N400 is that it's also sensitive to some extent to orthographic features. So it's reduced for a word that doesn't make any sense, but if that word is orthographically similar to an expected word, it's actually reduced compared to something that's completely anomalous. So in the current study, we used the gaze contingent display change paradigm. And so we had an identical condition, and then we also had an orthographic neighbor preview condition and a anomalous the. And all of these were high constraint sentences. We chose to do that partly to just amp up skipping rates to be able to actually compare between the two. And they were also all three-letter words for the same reason. And so then, after collecting the data, we split trials depending on whether people decided to skip or not skip the target word on that particular trial. So getting into the results. So basically, we pretty much perfectly replicated the skipping effect from Abbott et al. In their high constraint condition. So we found much higher skipping for the than even the expected target word. And the anomalous orthographic neighbor actually was not different from the expected word. And so then moving on to the FRPs. So again, we split these depending on skipping or non-skipping behavior. And so first, just looking at the skipping cases. So we did find a significant N400 effect for both the orthographic anomaly and the. And again, these are time-locked to the word bachelor in this example. So these are time-locked to the word before the word that was actually manipulated. Then if we look at when people fixated the upcoming word, so we see that the orthographic neighbor anomaly effect basically goes away. And interestingly, the effect is still there, which I'll get into a possible explanation of in a minute. So basically, I think the takeaway from this is that people are deeply processing words when they skip them, and they're able to access enough information, at least, to identify that, well, first of all, that a word like the is anomalous in the context, but also to identify even a subtle orthographic change from what they expected. And when they fixate, that doesn't seem to be happening. And so another interesting thing with going back to the eye tracking data and kind of, so we wanted to look at things that were happening downstream to try and better understand these effects. So we looked at regression rates out of the end of sentence, so after people had already skipped or fixated the target word. And what we found is that there were significantly higher rates of regressions when people skipped in general, but also in skipping cases, they were higher for both anomalous conditions compared to the expected one. So I think this also kind of aligns with the FRP data showing that when people skip the word, they clearly kind of identified that something was wrong and wanted to go back and repair it. And so in those cases, they're more likely to go backwards and try and figure out what went wrong. All right, so getting back to that, the N400 effect. So people have argued that there are cases of mislocated fixations, so people maybe have an intention of landing on a particular word, but they fall short or go a little too far. And for short, like three-letter words, around 10% of the time, they tend to actually undershoot if they fixated on it, that they have undershot and intended to skip it in the first place. So since the was only fixated around 30% of the time, we have speculated that it might be that this N400 effect in the cases is actually being driven by cases in which people intended to skip it, but they just fell short. But this, again, is speculative, and so we're planning to look further into this in the future. So another interesting thing about these findings is that the decision to move the eyes, so eye movements or fixation durations on words during reading tend to only be about 250 milliseconds. And that's exactly the case in this study. On average, they were 247 milliseconds on the pre-target word. So the N400 effect that is related to the skipping behavior comes after people have already moved their eyes onward. So how exactly can it be that skipping is related to this effect that comes after that's already happened? And so I think, so linguistic processing of the parafoveal preview results in this effect, but you would maybe expect that if people noticed that there was something wrong, they would decide not to skip it, and instead they're still skipping in these cases. So I think basically our explanation of this is that people are processing enough information from the parafoveal preview to kind of make an informed decision about whether they think they are going to identify the word, but it's not necessarily full identification and semantic access and integration before they make that decision. So it might just be like rough matching of orthographic forms to expectations, or in the case of the, it's pretty clear that that's a very familiar word, and I think I will be able to identify that. Yeah, so to summarize, I think these data show evidence that there's kind of a partial linguistic account of skipping, and so when people successfully identify parafoveal linguistic features like orthographic form or frequency, they're able to use that information to guide their eye movements forward. And skipped words are not just noise in the channel. It seems that people are able to process them bottom up, and they're even able to identify subtle orthographic errors in the parafoveal when they skip. So I think parafoveal processing gives a head start that allows for thorough semantic identification to happen downstream once kind of these lower level, earlier aspects of language processing have already taken place. And because people can go backwards during reading, so different from during speech, you can't make people rewind, but during reading, you can always go back. So if you've skipped something and it doesn't seem to make sense, you can always go backwards and try again. So I think this speaks to the idea that eye movements are in service of comprehension, but also efficiency, and there's kind of a trade-off between the two sometimes. So thank you. And so this was also an experiment for my dissertation, so I just want to shout out to my dissertation committee and my advisor, Liz Schotter, who's here. And yeah, thank you.
Thank you, Sara Milligan. That was a great talk. We have about 9 minutes for questions.
This was really cool. I want to pick up on a thing that you kind of ended with, saying that you can't rewind in speech, but you kind of can, because you can ask someone to go back.
That is a fair point.
Do you think that's a similar cognitive process compared to what you're looking at?
Yeah, I mean, that's interesting. I guess during speech, you may not hear what people are saying, and might not understand. So, I mean, it might be that this kind of noisy channel framework partly is...
Yeah, so I'm thinking about this in light of the Clarkian conversation as collaboration thing. And I've never put those two things together, so thanks for sparking that in my head. But
me either.
That's
super
super
really
cool.
Interesting.
Yeah. Awesome. Thank you.
Thanks.
Hi, thanks. This is a really fantastic talk, and really, I loved where you started going on that last slide, Jack Duff, Saarland University. And I was wondering if I could ask you to sort of go from where you were leaving off with this idea of skipping and a better notion of what it is to that old Rayner finding, and it also turns up in a few other places, Steinmoro's work about skipping in older adults and why this seems to be something that changes over the lifespan and what sorts of things might impact it. I wonder if you have any speculation about this.
That's a great question. Yeah, that's actually, well, one thing we've considered is that some of these effects might be related to individual differences in people. So if someone is more of a skipper, maybe they have a larger N400, for example. But yeah, when it comes to aging, I think, people have postulated that older readers are kind of riskier and tend to skip more and regress more maybe. I feel like that literature is very confusing, and people find findings in the opposite direction sometimes. But I guess, so I don't know that I can speak to that, but I think that there are definitely individual differences in this, and I think that there are probably individual differences that can shift the kind of contingency and relationship between these things. So there might be people who are kind of lower skilled readers who just skip more because they want to get through it, and they don't care as much about deeper comprehension, for example. So all of that is stuff that we definitely want to look into more.
Cool. Thanks so much.
Thanks.
Hi, I'm Matt Husband, University of Oxford. I wanted to think a little bit about the temporal paradox that you were talking about, and wonder if you had thought to look at fixations, like the next fixation, and then look backwards in your ERP record to see, is anything going on prior to the landing point of that fixation that might be driving this kind of question about whether they're over or undershooting, or whether it's something more like a rational inference that's going on in that. I wondered if you had thoughts about maybe that using that kind of data that you already have to investigate that question further.
You're talking about time locking, backwards, kind of looking at maybe effects that were related to the Saccade decision or something like that?
Yeah, something like that, where that initial, you have this fixation, maybe you've made a decision, you land, you don't get the information you're expecting, something like that. Do we see evidence of that either happening before or what's going on after that fixation point as a time lock point? So I just wondered if you had thoughts about that, or if that would be an interesting data point to look for.
Yeah, we actually have wanted to do that, and I think it's interesting to try and identify some brain signal associated with eye movement guidance and stuff. I think the one thing that has hindered us as far as that goes is what do you baseline to? How do you just the practical aspects of it? But yeah, I absolutely think that's...
Yeah, in theory, you might even keep the baseline that you had before, because it's not clear that drift would have gone that far, given it's only 250 milliseconds, so maybe you can use that. Anyway, it's just a thought to consider. Thanks so much, appreciate it.
Yeah.
Hi, Francesco Vespignani, University of Padua. I like a lot the paradigm design, and the results are really, really good. And I'm wondering what happens if the two following words were not short function words. So my question, if I remember correctly, the result from Brainerd, you process most of the letter on the right, on the left, but also 3 or 4 letters on the left. So I'm thinking that independently that the subjects are not aware of the change, maybe the brain realizes something is changed there. So I was wondering, this is not to criticize, I think it's really an N400, but maybe superimposed is the same time of the next fixation, more or less, if there is some frontal mismatch, negativity stuff or something like that.
Yeah. Yeah, we're also interested in trying to do some deconvolution, so, modeling the effects that are happening to the upcoming fixation. I think there are a lot of things that potentially need to be controlled for here. But yeah, I agree. Thank you.
Thank you.
Hi, Sarah. Great talk. I'm just wondering about, maybe I'm misunderstanding, but I'm wondering about the orthographic anomaly effect, right? So you're seeing N400 on the pre-critical word, right? Well, I mean, it's time locked to the pre-critical word, and you see an N400 enhancement when the preview is anomalous. But then when you land on the word, the N400 is gone. And so I'm just wondering, do you want to think of that as the ERP to the critical word? It could be that the N400 is enhanced because you've lost some contextual support from the right on the word that you're sitting on, right? And so and then when you go forward and if you happen to land, if you fixate on the anomaly, then you get this, looks like a reduced N400 and then a late positivity, which is something that's been seen before, right? I mean, we've seen it, and Dorothy Chwilla has seen it, and I think Rachel Riskin seen late positivities to essentially misspellings, right?
Yeah, I think the important thing here is that they never land on the anomaly. So the only time that they've been able to process it is
Right.
in that parafoveal preview time period. I do think it's like a curious pattern, right? That it goes away when they fixate it. But I think our take on that is that when people skip because they've had the opportunity to shift their attention forward and engage more.
Right.
And so there, I think, are differences in circumstances and times where if you haven't had the opportunity to shift attention forward,
Right.
you might decide, I need to fixate this word. Whereas if you skip it, then it's associated with having kind of already processed it. Does that answer your question?
It does, but would you agree that there's some question about whether these ERPs are reflecting the difficulty of processing the word that you're sitting on, the pre-skip word, or whether it's difficulty resulting from processing the thing that's in preview, right? Because these are all ERPs time locked to the word, to the pre-critical word, right?
Yeah,
So
I
it's-
guess these were counterbalanced across, so the preview condition showed up in all the same sentences and were counterbalanced across that.
Yeah.
So, I think that that's something else that we would like to look at in deconvolution potentially is like using frequency of the pre-target word as a covariate. I think that they're obviously these are not carefully controlled like a typical RSVP study. So there's a lot of kind of jitter and noise and other things going on and other decisions. So I think that there is a potential that, some responses are coming from what they are looking at, what they end up landing on.
Thanks.
Hi, Parisa from Penn State University. So thank you for this very interesting research and presentation. My question is, have you looked at when people consciously skip over some words, like when they're trying to read a text fast versus when they unconsciously, like because of fatigue or if it's ADHD or all other these reasons, skip some words while they're reading the text?
Yeah, I mean, I think that there are definitely kind of motivational and task differences. Like if people are just trying to like skim through something versus like deeply comprehend it. And I think that that's one thing we're interested in looking at is kind of if these contingencies shift around depending on motivation. I think the one thing I will say is that people, like the layperson who's reading, I don't think they have any idea that they're skipping over words. Like they think they're looking at them all directly. So I don't know that it's necessarily a kind of like conscious, like,
I mean,
intentional thing,
isn't it
but-
like a strategy that people use in order to be able like to study for exams or just things
Yeah,
like
I mean,
that?
I think some people skip a lot more than others, and I think probably in some circumstances, like, yeah, if you're cramming and you're like, I have 10 minutes left, like, read this last chapter. Yeah, I think you're probably going to do a lot more skipping and possibly less comprehending while you're skipping.
Okay, great, thank you.
Thanks.